Our capstone project is a secure password manager made by team members Michael McLean, Donald Furnival, and myself, Dennis Shelby. Our web-based application is designed to help users securely store and manage their passwords, offering a streamlined, accessible, and fully functional solution with strong security practices. I was responsible for developing the front end of our app, so I'll give you a quick demo to show you how it works as well as my contributions to the project. This is the landing page for our app. It describes its purpose and how it can benefit its users. It also has a link to sign up for a free account, which I will do now. Once registration is complete, you can proceed to your dashboard. This is where you will have access to all your stored passwords. To add an item to the list, click Add Credentials, then enter the account name, username, and password. Click Submit and you'll see the new item added to your dashboard. I'll add one more item. On the right side of each item, you'll find three tools. The first copies the password for the account to the clipboard. You can then paste it into the login page for that account. The next tool allows you to edit the credentials for the item. And finally, you can delete the item. In the account settings, you can enable multi-factor authentication using either an authenticator app or by receiving a code by email. To enable, scan the QR code with your authenticator app and enter the 6-digit code to complete your enrollment. Finally, we have a user guide with detailed instructions on how to set up an account and use the app. I used React to build the front end of our app, and we opted to handle data encryption client-side to achieve end-to-end encryption. I used the web crypto library for encryption and decryption of user data. And here is a list of the features that I just demoed. So why React? Its component-based architecture allows for self-contained reusable components, which promotes modular code that is easier to maintain. It uses a virtual DOM to only update the parts of the UI that have changed. It integrates well with our Django backend, and there is a large community of users for support. And Web Crypto was a logical choice for encryption. It allows for client-side operations, and it is built into modern web browsers. And that wraps it up for the front end.
Hello, my name is Donald Furnival. I mostly worked on the back-end API part of this project. I'm going to briefly go over the design and implementation, how it works, and some of the reasons for the decisions we made in the design. Our backend is built with Django REST framework, providing a secure RESTful API. We use Swagger to automatically document endpoints, request response formats, and authentication rules. Key features include secure, session-based login, multi-factor authentication via email or time-based codes, and password vault management. For security, the backend only stores encryption algorithm details. Encryption and decryption happen entirely on the front end for true end-to-end encryption. We also enforce a custom permission that requires MFA before any vault access, adding another layer of protection against compromised accounts. We chose Django REST framework for several key reasons. First, familiarity. Our team is already comfortable with Python, so working with Django and DRF was a natural fit that allowed us to start quickly. Second, DRF strikes a balance between development speed, powerful built-in features, and the flexibility to customize the API exactly how we need it. It comes with essential built-ins and easy-to-use libraries, including authentication and permissions through Django Auth, automatic API documentation with DRF Spectacular and Swagger, and serialization and validation out of the box. Customization is simple. DRF permissions are straightforward to implement, but flexible enough to handle complex access rules when necessary. Finally, the development support is outstanding. Both Django and DRF have excellent documentation, a robust and well-tested codebase trusted by many enterprise applications, a large and active community, and extensive third-party libraries that helped us integrate features quickly and securely. All of this meant we could focus more on the unique challenges of our project, instead of reinventing the basics. Here's our Swagger UI, which is automatically generated from the Django REST framework schema. It serves as both live documentation and a testing interface for our API. Each endpoint is clearly described with its request parameters, response formats, and authentication requirements. This helps both our team and future developers quickly understand how to interact with the API without digging through back-end code. The UI also lets us try out endpoints directly, which speeds up development, debugging, and integration testing. It's especially helpful when validating new features like MFA or Vault access permissions. Here's the overall structure of our project. We've organized it into 3 main Django apps. Accounts handles user registration, login, and multi-factor authentication. This includes utilities for TOTP and SMS MFA, custom serializers, and views for managing authentication flows. Vault manages the secure storage layer for user password entries. This is where we enforce our custom permission that requires MFA opt-in before a user can access their Vault. API provides a central place for exposing and organizing API endpoints, along with their associated views and URLs. At the project root, the Password Manager directory is the main project configuration and contains the main Django project settings, utilities, and routing configuration. We also have a front-end directory for static assets and our React single-page app build. The React build is separate from the Django project and injected into the Django setup when built. We also keep the back-end tests directory for automated unit tests and a schema.yml file that defines the OpenAPI schema for our Swagger documentation. A script has to be run manually to update the schema definition. This structure keeps each part of the application logically separated, making it easier to maintain and scale as the project grows. This diagram shows the basic flow of our application from the user interface down to the database as it concerns the back-end mostly. On the front end, we have a React single-page app with React Router managing navigation. All API calls go through our Django REST framework backend, where Django's URL routing sends requests to the right views. The account views handle registration, login, and multi-factor authentication, enrollment, and verification, while the Vault views provide full CRUD operations for stored credentials. Data flows through serializers for validation and formatting before hitting our models, which include user, user profile, Vault item, and Vault item history, and is ultimately stored securely in Google Cloud SQL.
Okay, so now we're going to be going over the infrastructure for the app. So for a quick overview, the main app and the database are hosted on Google Cloud Platform. The service will automatically scale with more traffic to the app, and the load is going to be distributed evenly with a publicly exposed load balancer. So this means that the service will have a high availability to our users and mean that the service will be highly performant as high amounts of traffic won't create a bottleneck. Incoming requests are screened by GCP's cloud firewall to make sure all connections to the app are secure, enhancing the app security. And the app leverages Google's Cloud SQL auth proxy for secure internal database connections to make sure that only authorized users have access to the password vault. Here's a diagram of the app's infrastructure. So users are first screened by the firewall. Then after the cloud DNS resolves the IP address, the request is sent to a load balancer where the user is then redirected to one of the virtual machines running the app, or a new virtual machine is spin up if necessary. The backend connects to the Cloud SQL proxy to get the user's password vault, and that information is then returned to the front end. So every step along the way, we're ensuring that requests are handled securely. Why did we go with GCP? So first, it offers a lot of simplicity, especially when it comes to global networking and load balancing. Other services like AWS require multiple services to be running at the same time to reach the same level of reach that GCP has, which complicates the configuration of the load balancing. For security, Google offers Cloud SQL auth proxy right out of the gate, so you can just add that as a sidecar to your project and create secure connection to your database very simply, very easily. And Google has no requirement for a public IP address for their databases. Some services like AWS require that, but that can create some security concerns since the database can be accessed publicly through that IP address. Scalability, like I said, new VMs can be spun up as necessary on Google Cloud. And lastly, pricing. So GCP offers very competitive pricing, and they offer a flat fee for load balancing, whereas A lot of other services, AWS and Azure, usually require or usually have a increasing price for increasing demand. So major contributions. My major contributions to this project were, again, just for infrastructure, configuring the database on Google Cloud SQL, implementing the HTTPS setup, and configuring the cloud ready deployment for Django. All these things, I was just on the Google Cloud console every day, trying to make Docker images out of our application, uploading them to the artifact registry, setting up the VMs, setting up the instance groups, setting up load balancers to create new VMs as required, redirecting our DNS queries to our load balancer's public IP address. I attempted to create some CI/CD pipelines for this, but that ran into the challenges section. So there was some strange VM behavior where earlier versions of the application were running fine. Then I tried to update them, and those new images and the VMs that were running them just broke. So I had to start from scratch, create new VMs, learn why different operating systems worked differently on these VMs, and then how that impacted the function of our app. There's some network configurations on the application side that I had to go into and fix. Um, all of this, all these different nuances between the configuration on the app side versus the configuration on GCP side took up the majority of my time on this project. And all of it was to make sure that when you went to secure login manager, our app was running. So I'm sure Dennis and Donald are going to be going over functionality of the application from here. So I'll leave that to them. But yeah, most of my contributions were squarely in the infrastructure side and making sure everything, our application would actually run at this website, at this URL.
So that is the current state of our secure password manager. There are other features that could be added. It could use a browser extension to autofill credentials, a password generator, and other minor improvements. But as it stands, we feel it's a pretty solid app.